My name is Jackie Tran. I go by he, him. I'm in my first year of the MELS graduate program here at Brandon University, and I am currently studying amphibian pathogens and disease here in Manitoba. Chytridiomycosis is an infection caused by two fungal pathogens. One is called Chytridium dendrobatitis, and the other is Chytridium salamandrivorans. And for obvious reasons, I will just refer to them as BD and B-cell. It's a panzootic infection, meaning that it only infects amphibians. The wood frog, northern leopard frog, boreal chorus frog, tree frogs. So we'll be swabbing those for BD. For B-cell, because it only affects salamanders, tiger salamanders, spotted salamanders, we're swabbing everything. Chytridiomycosis, it's a fungus that attaches itself to the outer skin layers of amphibians. They perform a lot of their important vital functions through their skin. It causes their skin to basically thicken up, prevents them from their regular gas exchange, and in most cases, the result is 100% mortality. So it's just one of the many fungal pathogens that are affecting life worldwide. There's also the white nose syndrome that we see in bats. If we're looking at agriculture, there's fusarium, for an example. So it's definitely one of the bigger fungal-related pathogens that we're trying to combat worldwide. We're partnering with a student network surveillance program for this specific pathogen called SNAPS, and we're following their sampling protocol. So what that looks like is we'll be out in the field for this project. We will be capturing frogs, salamanders, we'll be swabbing them with a kit. So just imagine COVID testing, but going out, capturing them and swabbing them, putting them in tubes, and we'll be sending them to a lab for genetic molecular testing to detect presence or absence of these pathogens. Research has been done in Ontario, and they have done species distribution models there. The white shell area, that could be our first point of contact. Even up at Riding Mountain, we can definitely look at this disease's spread is because of human activity. Anywhere there are amphibians, just about anywhere, probably even down the street from where I live. Fungal pathogens affect nearly almost every walk of life. In agriculture, it can be expensive to maintain. There could be loss of yield. When you translate that to wildlife, there's a loss of ecosystem services when organisms or species are being affected. Amphibians are incredibly, and I cannot stress enough that they're very important to the natural ecosystems that they belong in. They are both predator and prey, so in the trophic cascade, they do add a lot to their respective wetlands. They're known to be bioindicator species. Because they are so sensitive to their habitat, we can kind of use them as a way to gauge the health of an ecosystem. In a wetland, if there are no amphibians, then we know that it's not a thriving ecosystem. It's really important that future generations get to enjoy the ecosystem services that amphibians and other wildlife have to offer. In Manitoba and Saskatchewan, there hasn't been a full-on published data or peer-reviewed literature regarding these pathogens, specifically BD. It's pretty cool to establish this baseline data here. I'm going to be building what's called a species distribution model here in Manitoba. It takes an environmental layer and it stacks them and shows you the most suitable habitat for this disease. What that will do is it'll help us figure out these areas here in this province are the most at risk of BD proliferation, where they might be able to reproduce and infect. There's a very high chance of BD being here because if you look at a positive or negative detection map of BD, Manitoba and Saskatchewan are flanked by positive results. And of course, those are political borders, but with wildlife and plants, there are no such thing as political borders. They just go wherever as they please. The hope is that my data will serve as a baseline to at least get things started here in an event of introduction of another pathogen, such as B-cell. BD is already here and has unfortunately caused a lot of damage. So if we can somehow mitigate those events for future impact, we can build a protocol here in Manitoba, we'd be off to a great start. So far, Chytridiomycosis has affected 700 species of amphibians, 500 of which are at a steep decline in population, 124 species of which have experienced 90% decline in population, and about 90% of species have gone extinct. If we can somehow mitigate further damage and play whatever part that we can, there's a huge geography component to it too. We do have a lot of wetlands and a lot of suitable habitats. The data has shown us wherever amphibians are, this disease is there. When you add that complexity and that extra layer of human activity here, there's a very high risk that we could amplify this disease where we are from one end to another. So far we don't know exactly how, but that's what we're hoping to assess for in this project. My work is very fitting for my graduate program. It's very interdisciplinary in nature. There will be a lot of aspects of immunology, so learning about the vertebrate immune system, a lot of animal physiology, how environmental stressors can affect their response and their recovery to this disease. There's also a lot of policies and regulation from government or recommendations from the organization. So just drawing a lot of the partnerships and stewardships that we're hoping to gain with this project, and hopefully put in some protocols for the general public if they wanted to be a part. There will be lots of statistics involved as well too. We're hoping to use statistics to our advantage to predict the outcome of the pathogen here. We won't be able to have an effective measure or protocol put in place if we're not getting that external help from non-governmental organizations and also governmental organizations alike. One of the biggest things I can think of is getting the public involved, trying to change the public's perception about amphibians a little bit. If we can somehow get everyone on board, including government, stakeholders, landowners, this idea that amphibians do contribute a lot to the ecosystem, the environment. And hopefully at the end of all of this, everyone can work together and help fend off this pathogen. I've always known myself to have been a wildlife person. I've always vouched for wildlife. I've always been protector of the trees kind of person, but agriculture was a bit of a change for me. That's not to say that you can't have agriculture and not be sustainable and not care about wildlife and native species. That is what stewardship and policy and citizen science, that's where it comes in. It's definitely opened up my eyes a little bit. It's conservation and protecting wildlife isn't easy. You don't fast track there. There's obviously lots of hoops you have to jump through. You have to consider landowners, what their goals are, what they want to see on their land. I would say that the biggest thing that I've carried over from my background in agriculture to wildlife conservation is that partnership and communication is incredibly important, and really just broadening and widening your perspective and making sure everyone's needs are met, but at the same time protecting and conserving wildlife as much as possible. I really look forward to being outside because here field season is very short. As soon as the snow touches the ground, it's over. Field season's done, depending on what you're doing. I just look forward to being outside again and hopefully being a part of that conversation to raise awareness to amphibian and reptile disease here in Manitoba.